Hi. Today, kids, we're going to talk about domain and range. Okay? Domain and range are oftentimes misunderstood, and it has everything to do with number sets, and what your teacher is actually like testing you on is your understanding of what actually are functions and what can be. So if you want to pause this and go ahead and do yourself a favor and watch one of the videos, you can YouTube search them, how it's made. Okay, there's a British show and there's a show here. I think I don't know what network it aired on. I don't remember right now. Probably the Learning Channel. I'm not getting paid by them, but find yourself like how it's made candy or how it's made donuts, because that is domain and range. Okay, is the idea of something goes into a function and something comes out, and what is allowed to go in and what comes out. Okay, so that's what we're going to talk about today, but we're of course always going to be doing it through mathematics. So there are a couple of different functions that I want us to look at of domain and range. So first of all, let's just give you a couple examples, and I will hopefully have them make sense to you. Okay, so we're going to go pretty simple. Y equals x squared, y equals square root of negative x, and y equals 1 over x plus 2. So I hope we're not going to get any glare, but these are my examples. Okay, write these down if you need to. Y equals x squared, y equals square root of negative x, and y equals 1 over x plus 2. Okay, these are all very different functions. Now, let's think about number sets, okay? We've got real numbers, we've got integers, we've got whole numbers, we've got rational numbers, right? So I'm going to just cut to the chase right now. Your brain should think all real numbers at the jump, because most functions you can put anything in and you get anything out, okay? Domain is what you put in, okay? How do you make the donut, right? You want sugar, not salt, right? That's the domain. The range is what you get out. So mathematically, the domain is linked to x, okay? So domain is essentially allowable x, and range is outcomes of y, okay? Outcomes of y, okay? And to be super duper clear, y is the same as function of x, okay? So this is function notation. Y is equal to the function of x, okay? So these could all just say f of x, f of x, f of x. So what that notation is saying, what this notation says, okay, is x is the input. I forgot my computer shuts down on me. X is the input of the function. X is the domain of the function. So function notation, a lot of people find this to be easier because it makes sense because you've already got the x there. Some people find it prohibitive because y has always been synonymous with the graph. Okay, y and f of x are the same. Y, WHY, do math teachers teach it to you this way? I don't know, and honestly, I have tried to stop it, but it's become prohibitive and it becomes very confusing to young people. Okay, but y is f of x. Okay, so if the domain is the allowable x and range are the outcomes, the allowable outcomes of y, let's look at y equals x squared. Okay, so I'm going to erase my domain and range. Hopefully you have that written down. We'll put it right. So y equals x squared. Okay? What are we allowed to put in? Okay? And the reality is, are there any bounds on the square root? Now again, domain and range is testing if you understand what's going on. So I would highly suggest that you make yourself a little sketch. So I picked the easiest one. I picked x squared, but if we had something different, it would change the vertex. And in fact, maybe I need to do that. But this is a parabola, right? The graph of x squared is the graph of x squared is essentially a parabola, right? So the vertex doesn't move. You have to know your vertex. When you're talking about domain and range, it's a higher order understanding of the equation, okay? The actual answers are pretty easy. But what your teacher is testing you on or asking you about is, do you understand the nature of what's happening? Like I said, you don't put wood chips into the donut maker, right? Likewise, you don't put sugar into when you're trying to make cement. What is the function? Conjunction, junction. What's your function? That's for my Gen X friends. Okay, so x can be anything, right? These arrows mean it goes on to infinity. So whoop, forever. So even though it doesn't look like it's going over here, eventually, as we go infinitely high, it's going to go infinitely that way, infinitely that way. But my question to you, so that means that our range for our first example, or excuse me, our domain, what we're allowed to put in, is what we're going to say all real. And we're going to use the real symbol like that. You could say, another way to say all real is infinity, negative infinity, x, positive infinity. Negative infinity, x, positive infinity is another way to write all real numbers. This is the most mathematical, though. This is the most, I'm a mathematician, I'm going to write it this way kind of a thing, right? It's like I could communicate to you, where are you, via text. And I could write out the whole thing, where are you, and capitalize the W and put a question mark. That is high-level English language grammar. Or I could put where, lowercase, the letter U at, no question mark, right? Does it convey the same thing? Yes. But is it like kind of lower order? Like, also yes. So this is, I 100% get what's going on. This is mathematician. This might be what your teacher wants because it has x, but these are the negative infinity, positive infinity. That is your domain, is all real numbers, okay? But wait, there's more. So now let's talk about the range. And to do the range, we have to consider what it can be. So let's look back at our sketch. Now, do you need to sketch this every time? No. But would it help to have a little bit of a sketch? Yes. At least early on. So let me ask you this. Now, the range is y. Y, these are all the positive values of y, right? Will y ever be down here? And the answer's no, right? Because it's the nature of what squared is. If I take negative 5, which is allowable in my domain, if I put negative 5 multiplied by itself, negative 5 times negative 5, becomes positive 25, right? So every negative you put in here becomes positive by the nature of the function. That means that the range is exclusively positive numbers, okay? So range, now do not get range confused with all real. Do you see the double line? That means a number set. And I know my handwriting gets bad, but every teacher's handwriting gets bad. Every student's handwriting gets bad. This big R means range. This double R means all real numbers, okay? That used to confuse me. So what we're saying here is y can only be positive, okay? Y is only greater than 0. And we again could say the function, okay? So that's our first one. Let's see if we can get this second one without the graph, okay? So those of you in pre-calc level are hopefully understanding that this reflects if it's external, right? It's going to reflect it vertically, and if it's internal, it's going to reflect it horizontally, okay? So actually, our graph is going to look a little bit like that, I believe, right? So let's think. We have a square root. So I'm going to you've seen this, but I'm going to erase it, okay? I know that sketch. Y is equal to square root of negative x. Now let's ask ourselves, okay, can when you take a square root, because we're not dealing in the complex plane right now. If you know what the complex plane is, bom dia. If you don't, we're not dealing in it anyway. Okay? The complex plane involves imaginary numbers, and imaginary is exactly what you think it is. So we're only dealing up to real numbers. So am I allowed to put all real numbers into this? Am I allowed to do that? Well, if I put positive numbers in for x, I'm going to get a negative. Can you take, it goes back to my negative 5 times negative 5 is positive 25. These are inverse operations. The square and the square root are inversions of each other. Hopefully you know that. Okay? So if this is an inversion, can I ever get out a negative answer? Can I even take the square root of a negative number? The short answer is no. Okay? So does that affect our domain? What we're allowed to put in? Yes. Now let's analyze again. Because I made this negative, what we want to exclude from our domain is actually the positive x. Because positive times this negative becomes negative, and you cannot take a square root of a negative number. So we actually want all the x values, all the domain that already are negative. So we would say our domain is, and I actually could have put all real, but real numbers such that x is less than or equal to 0. So I want to, math is a language, I want to read this for you. This says domain is all real numbers such that, yes, a colon means the phrase such that, x is less than or equal to 0. Okay, these are hieroglyphs. This is shorthand. That's why math is brilliant and also difficult, because it's universal. This is a sentence. It says in an idea sentence. The domain is all real numbers such that x is less than or equal to 0. What that also means is x can only be negative. Okay? All right. So when you put in all these negatives to get out positives, what are we going to get in the range? Well, the range is going to be the same as this one, because it'll never be negative, right? Because you can never get a negative square root. So the range is the same as this, but we'll write it with the all real and the such that. Okay? The range is all real numbers such that y is greater than 0. Okay? What that's saying is I'm taking all the positive real numbers. Now, you can write this with the bounds of negative infinity, or 0 less than or equal to y less than or equal to positive infinity. Okay, you can do that. But I'm trying to give you the math speak. Okay? Okay, last example down here. Let's look at it real nice. Y is equal to 1 over x plus 2. Okay, can we put anything into that? And the answer is we can put anything into it save one number. And this goes down to fractions. What can the denominator not be? AKA, what makes no sense to divide by? It's not that you, air quotes, cannot divide by this number. It's that all the universe breaks down. Nothing exists. It doesn't. What can you not divide by? 0. So you can't divide by 0. So if you're not allowed to divide by 0 / it doesn't exist, what would be the range? This can be anything you want it to be except for one number. And it's the number that makes the equation 0. Read it with me. The domain is all real numbers such that x does not equal -2. Does not equal. Okay? Because when x is -2, -2 plus 2 is 0. And no good. No bueno. Now, the range, does excluding that x mean that it changes the range? Now we have to kind of think outside the box and just sit with ourselves, right? Now we could graph this, okay? And it's going to look like a curve. But you go, well, if I put in a big negative number, that's going to be a really tiny, if I put in a super tiny negative number, right? Like this actually can be pretty much anything coming out. But let's do a little sketch graph of what happens as we approach -2. So when x is negative 1.5, right? This whole thing this is going to be 2. So as I approach, here's -2, and this is going to be, it's going to get bigger. The closer I get to this, it's going to be bigger, 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 bigger. And then it's going to actually have a spot where it's going to flip over, okay? And let's see, if I approach from the other side, if I have negative, then it's going to be hugely negative, so it's going to come down here. And then -2 is going to be what we call an asymptote. But what it does is y, or the range, can still be everything. So that's still going to be all real numbers, okay? But do yourself a favor and do a little sketch. Desmos.com. I'm also not getting paid by them. But Desmos is a great way to check. And then you can see what's going on with domain and range. And you can check with all these, but you still have to understand how to write it, okay? So range is all real numbers. Domain is all real numbers such that x cannot equal -2. This is how the notation works, and it's how the brain works. Domain is everything you're allowed to put in. Range is everything that you get out. Have a great day. See you later.